My name's Jake Wheat. I'm the senior architect and lead developer at SQream Technologies. I've been working here for 3 years.
Okay. And what brought you to SQream Technologies?
I was contacted after I put some of my Haskell code online by the guy with the original idea.
Okay. How long have you been a Haskell developer?
Just at this company for 3 years. So I started learning Haskell about 2 years before that.
Okay. What led you to learn Haskell?
I was interested in relational database theory. And I was working with that and thinking about how to design applications using that. And I was using SQL, and I found the awkwardness of SQL syntax and the clumsiness and verboseness was getting a bit too overwhelming. But I didn't want to switch to a combination of, say, SQL and another language. So I decided to try and learn how to write an SQL parser to work with the syntax. For some reason, I tried most of the other possible languages before finally coming to Haskell, and I struggled with all of them. I struggled with Common Lisp and Scheme, and Objective-Camel I also tried out. But eventually I came to Haskell, and it was incredibly easy. And I started writing a toy parser to parse a couple of SQL statements, simple queries. And after a few weeks, I found I was able to easily parse huge amounts of SQL. So it was extremely easy. I was very surprised.
So how'd you
from that?
How'd you go about learning Haskell?
Just looking online. I bought a couple of the books. I can't remember the names now. There's Haskell School of Expression.
Okay.
And there was another book by Graham Hutton. I've forgotten the name now as well.
Great.
But mostly your websites, various tutorials online.
Okay. And could you go a little bit more into the languages you were using before Haskell?
Yes. Well, this project I was writing in SQL. I was working with PLPG-SQL and also Ruby.
Okay.
I was quite frustrated by the lack of typing in Ruby, which made a lot of things much more complicated. I thought there was a lot of difficulties working with the code and working out if the code was correct and everything fitted together. And I had a background in languages like Java and C++, and unusually I like the type systems in these languages. I like to use them. I was missing that in Ruby. Before that, I was working in Visual Basic, doing web applications mainly.
Okay. As you learned more and more Haskell, did you see other places that you could apply it in your current work?
Yes. Well, in the current work we started with Haskell from the beginning. So the first code was written in Haskell, so it was there from the start. But yeah, I think Haskell is an amazing general-purpose language, and I use it by default for everything, any task that I want to do, scripts, applications, testing utilities, and anything that I want to code up by default. My first choice is Haskell. Probably over half of our software is written in Haskell. I can't imagine doing it in another language. I can't imagine how to do a comparison.
Okay, great. Well, let's go ahead and move into how SQream Technologies is using Haskell.
Yeah.
So could you give me a little history of SQream Technologies?
Yeah, it was conceived about 3.5 years ago by a guy called Kostya Barakin, and he decided that he wanted to write some accelerated database queries using GPUs, and he decided the technologies he wanted to use included Haskell. So he looked online and found my SQL parser in Haskell and approached me, and we decided to work together on the project. So eventually the idea sort of evolved, and now we're writing a full SQL database management system for analytic queries. And Haskell plays a major role in that. It's used in compiler, where we take the SQL queries and compile them down to low-level instructions, which we later run using code written in CUDA.
Okay.
By using GPUs, we can write code that can deliver fast results with much less hardware. So essentially, it's a cost thing. We can try and run queries that other products would run on hardware that might cost hundreds of thousands of dollars, and we're running it on a $20,000 box instead.
Oh, cool. Could you give me an example of a customer? Well, not necessarily a customer name, but like what? How would a customer use you?
One of the main areas we're targeting at the moment is telecoms companies.
Okay.
So, analysis of phone call records for a variety of different reasons. At the moment, we're looking at billing software.
Okay.
It turns out to be a very difficult task involving a lot of optimized code, and a lot of companies are really struggling.
Okay. So how does Haskell fit in with the other tools that you're using to deliver your product?
Well, SQL's a very, very big language, and it's a slightly weird language.
Okay.
It's quite tricky starting with SQL and then producing something at the end that you can implement easily to run at high performance. And then since we're using GPUs, there's additional challenges. It's very difficult to understand the best way to implement SQL on the GPUs and to fit everything together. And there's a lot of coordination and different steps required. Fitting together all these complicated bits, Haskell kind of sits in the middle, and it's never a problem. We have a lot of difficult things to work on and to deal with, and Haskell kind of sits in the middle and always delivers very easily. So we struggle how we're going to produce a particular CUDA code or how exactly we're going to implement a particular query. But once we work that out, then we can stick it all together with Haskell, and there's never any problem on that side of things.
Great. Do you, outside of the compiler, are there other areas where you're hoping to implement Haskell?
Yeah, so a lot of the system was prototyped in Haskell with a very small amount written in CUDA originally. We've been moving more of that into C++ for performance reasons, but there's still a lot left in Haskell. Then as we prototype new features, we often use Haskell first, and there's quite a few supporting tools that we use in development, such as testing utilities and build systems, which were written in Haskell as well. So it's kind of the go-to language for a lot of the utilities we write to help us. And we also have our command line utility that we use for customers. It's also written in Haskell too. So it's pretty much anything apart from the high-performance codes that runs on the metal, we're writing in Haskell.
Oh, very cool. How many Haskell developers do you have?
We have 4 Haskell developers at the moment.
Okay. And what are the future goals for SQream Technologies? Do you plan to hire more Haskell developers?
Yes, I think we've got a new one starting next week.
Okay.
We're looking for more as well. So.
That's good. So the job market's good for Haskell developers.
Yes, we're struggling to find them. So anyone who knows Haskell who's in Israel, can come in for an interview.
Cool. Well, let's kind of switch gears one more time to what advice do you have for people interested in learning Haskell?
Well, there's lots of material online guidance for this. I'm not sure I have anything new to offer in that area, I think.
Mm-hmm. How about when you were learning, what hurdles did you have to cross, or were there any, or was it intuitive to you?
It was extremely hard, very, very difficult. I struggled with a lot of the usual things like monads and various other type classes, the syntax, the white space layout, and the incredibly difficult to understand error messages coming from the compiler. But I think it's just a case of keep going, and eventually it becomes very rewarding.
At what point did it become rewarding to you?
Well, the first code I wrote in Haskell was probably a replacement for scripts and things like that. So as using the IO monad style code started to click, it started to make writing the scripts very easy. And it's an overused phrase, but a lot of the scripts worked perfectly the first time. I don't think that's true for a lot of Haskell code in general, but for simple scripts, it was much superior to working with Bash, for instance, or Python. I think when I started working on the SQL parser, I was just trying to write a toy example, just to try a few things out. I got more and more drawn in. I started writing a parser that parse huge amounts of SQL and do type checking and all of that. It was the motivation to learn more Haskell to fit in with that, and then working very hard, and it all started to fit together. Once I got a basic fluency with Haskell, it became very easy to use it for lots of different tasks.
Okay. Talk to me a little bit about how the Haskell developers at SQream Technology collaborate.
Yeah.
Okay. I asked that because I've come across people explaining that Haskell is incredibly easy for other developers to know what one developer meant. So instead of having to interpret their code, it's much easier to see what the previous developer had intended to do and then to build on that work. So instead of rewriting, they're just adding.
Well, one of the main benefits is the code is often very short and concise, and it reflects a problem made very directly. So I think it's just basically you can understand someone else's code very quickly because there isn't a lot of the so-called accidental complexity, and the code says directly what it means rather than being implemented via some other ideas. I think the type system helps a lot, of course. If you take someone else's code and modify it, you're going to get a lot of type errors, which tell you what you need to fix up. Once you've fixed all those up, usually you've got working code after that.
How does that compare to your experiences before coming to SQream Technologies and working with different languages?
Well, I can compare it to SQream because we write a lot of C++ and CUDA code as well.
Okay.
Definitely much more of a challenge understanding C++ code and working with different people's C++ codes. It's much more verbose. There's a lot of extra details that you have to take care of. But I'm not sure it's a completely fair comparison since we're implementing the compiler in Haskell, which is a very natural thing for Haskell to do, and then we're implementing sort of complicated high-performance code in C++ and CUDA, which is quite an unusual thing, and there's not a lot of information out there about how to do it well. So we're kind of feeling our way out in that area.
Okay. So what are some of your favorite features of Haskell?
Well, the blog post covers two of my favorite features, which is the algebraic data types and the pattern matching, which is a very basic thing, which I like a lot, and the Uniplate generics library, which enables you to write all sorts of really powerful things very, very easily without lots of extra boilerplate, and it's very robust in terms of maintenance and modifying the code, adding and removing various things. It stays very stable and keeps working.
Well, in your opinion, why should somebody learn Haskell?
I think Haskell is extremely challenging, and I'm not sure if it's a language for everyone. I know some of the people here who are doing Haskell. We have 3 developers at the moment doing Haskell. 2 of them never looked at Haskell before they started here. They have a background in functional programming. They picked it up very easily, and they picked it up much more easily than I did. I find it very challenging, and it was a very long learning curve. It took a very long time, but once I got over that, it was an extremely rewarding programming language. And I have a background of about 10 years programming in other languages professionally, and I've learned more about programming and approaching programming and programming design and things like that in the last few years learning Haskell than I did in the previous 10 years.
Could you explain that a little bit more?
It's hard to say exactly why. I'm not sure I'm able to give a good analysis, but I think a lot of it's to do with the fact that Haskell supports very good abstractions in a way other languages don't, which means you can think a lot more about the problem domain, and I suppose it relates to the ability to write DSLs easier in Haskell. I think a lot of it comes also from the purity of Haskell as well, which means you have to restructure the way you do programs and think about programming languages. You can't get away with a lot of techniques you use in other languages, but once you've learned to live with those different constraints, you can write much clearer and more concise programs. And you can then take that knowledge back to C++ or Java and apply the same techniques there. Maybe the C++ and Java programmers aren't so keen on that sort of code, but you can apply a lot of the techniques and write code very succinctly in Java in a kind of a style based on Haskell.
Okay, great. Well, again, thank you so much for your time, and I appreciate you taking the time to answer all these questions.